Hey guys, for calculus, this is 2.5, and for pre-cal, when we start learning calculus, this comes from 3.2, and it is called implicit differentiation. So before I go in and explain to you guys what implicit is and looks like, I want to give you guys a scenario to understand what we're learning, okay? These next two lessons that you're going to learn go very hand in hand. So if you were sitting in my class right now, I'd probably take out a balloon and I'd start blowing the balloon. We've been talking a lot about rates of change and how things change. So you can agree that when I blow up a balloon, as time passes, the radius is changing and it's growing. And it's changing at a specific rate depending on how I'm blowing the air in. So for example, if every second that I blow, the radius increases 1 inch, we could say that the diameter, which is double the radius, is increasing it's at 2 inches now, a second later. So the radius is growing at one rate of a change, and then the diameter is growing at a different one. We could also say the same thing about the circumference about the balloon. It has its own rate of change that's taking place as time passes. We could say the same thing about the surface area of the balloon, and we could say the same thing about the volume. So in real life, as time passes and things grow or increase or decrease or shrink, different measurements and aspects of it are growing and changing at different rates as time passes, okay? So that's what the next lesson is going to look like. It's going to look like the real application of like these balloons growing, a ladder sliding down a wall, and all the different measurements that start changing. But in order to be able to see those real world applications, we need to know the technicality of it, the math, and that is where today's lesson, implicit differentiation, comes in hand. So implicit is just a fancy word for doing a derivative of a function that has multiple variables. Like the balloon has the variable of the radius, the diameter, the circumference, we're going to start seeing it first initially just with like x, y, or x, y, and z. Okay? So let's look at this notation really quick, very important. dy dx means the derivative of y, you read the numerator first, and then the denominator is with respect to whatever variable is there. So this one is with respect to x. In the next lesson, they will all be over dt because they will all be with respect to time, the time that passes. Okay, so that's very important. So what happens with implicit differentiation is when you differentiate a variable other than the variable that's with respect to, so aka the one in the denominator, you must include that variable's derivative as well. And the way that they explain it in the book is that they use chain rule. And I think once you start seeing the problems being solved, it'll start to make a little more sense, okay? So you have two notations that you are allowed to use in this section. I give my classes the freedom to pick whichever one they want. Whenever you go to say the derivative of y, you can say y prime or you can say dy dx, okay? And I'll do a little bit of both throughout this lesson so that you're exposed to both, and then you can pick which one you like. So if I'm doing the derivative with respect to x of y, I have to write dy dx or y prime. If I'm doing the derivative of x, which is what you've been doing in every lesson up until now with respect to x, we had said the derivative of x is 1, right? The reason why that happens is because the derivative of x with respect to x, dx over dx, is the same thing. It equals 1. It reduces, okay? Now, if I were to do the derivative of z with respect to x, I have to put dz dx, or I could put z prime, okay? So right now, this just sounds very arbitrary. As you go seeing examples, this is going to start to make a lot more sense, okay? So let's take one at a time. Okay? So if I were to do these derivatives with respect to x, I'm going to take the same rules that I've learned in the past, that each term has to get dealt with one at a time, okay? So I'm going to do this term first. You are going to treat this as a regular power rule, okay? And the book says to treat it as a chain rule because if I do derivative of the outside, I'd multiply the 2 to the front. So I would get 6. I'd rewrite the inside. This exponent would have gone to the first power. And then when I do times the derivative of the inside, derivative of y with respect to x is dy dx or y prime. So this time I'm going to use this notation, okay? Plus. Now I go to the next term, okay? Derivative of the outside, 4 times 2 is 8. rewrite the inside, and it's now to the third power, times, if it's derivative of x with respect to x, you technically don't have to go through the motions of writing this. I'm going to write it so that you see that this is going to become a 1. Next term, minus derivative of the outside, 3 times 4 is 12. Rewrite the inside. Now it's to the second power. And then derivative of the inside is derivative of z with respect to x, so that's dz dx. Equals, and then I have one term on the right side of the equal sign. Derivative of negative 5, that is a constant. Derivative of constant is 0. Okay? So my last step would just be to change this dx to a 1. Okay? So my final answer would be 6y dy dx plus 8x cubed times 1 is just itself minus 12z squared dz dx equals 0. Now, one rule of thumb that I tell my students is anytime you are doing one of these problems and you're going term by term, if the variable is anything other than what you're with respect to, then you have to do the implicit step. If it is the same variable, if it's the same variable that you're doing it with respect to, so for example, here I did derivative of x, and it was with respect to x, you can skip the implicit step because it'll always give you 1. So I go down my line. Here I'm going to have to add my dy dx. Here I'm not. Here I'm going to have to add my dz dx. Okay? And you can see those are the two that came out. So let's look at a simpler problem. Y cubed. It's just one term. Do the derivative with respect to x. Well, that's not an x, so I know that I'm going to have to do my implicit step. So derivative of y cubed is 3y squared. And because it is not the same variable that I'm doing it with respect to, I have to put my dy dx, or this time I'm going to put y prime just to show you a different notation, okay? And that's my final answer. So again, this answer over here could have been written with a y prime and a z prime, just like this one could have been written with a dy dx, okay? So on this next one, I'm doing the derivative of x cubed with respect to x. Since x is the same variable that I'm doing it with respect to, I can completely skip implicit and treat it as a normal power rule. I don't have to write the dx dx. If you do, just know that it reduces to 1. But this is your final answer. Okay? Next one. Derivative of x with respect to x is just 1. I don't have to do implicit when it's the same variable. Plus 3y. Y is a different variable than what I'm doing it in respect to. So here I do have to do implicit. So first do your normal derivative. Derivative of 3y is just 3. Okay? And then times, I have to do implicit. Feel free to put dy dx or to put y prime. Okay? Now, I cannot add this 1 and this 3 because PEMDAS says I'd have to multiply first, and this 3 is attached by multiplication to this y prime. Okay? All right, let's pump it up a little bit. If I'm doing the derivative of x times y squared, this is the first time that we're seeing it separated by multiplication instead of by addition and subtraction, I do have to take the product rule into account because there is multiplication. So now I'm starting to combine these rules. I have product rule, and because I'm doing it with respect to x and there's a variable other than x, when I do the derivative of that variable, it will have to include implicit. So let's say product rule says derivative of the first, so derivative of x is 1. Rewrite the second. I'm not doing a derivative, so I don't have to do implicit. Plus, rewrite the first times derivative of the second. Now that I'm doing derivative of the second, now is when I have to take implicit into account. So, do our regular derivative, 2y to the first, times implicit. If this is derivative of y with respect to x, you can either put dy dx or y prime. And if you clean this, you'll end up getting y squared plus 2x y prime. Okay? Just combine things, put my coefficient in the front. Now remember, product rule, you could have done first times the derivative of the second plus derivative of the first times second, and then your answer just would have come out the complete opposite order, which again, this is addition, so that is completely okay. So now that you understand how to apply the derivative of a variable other than what you are in respect to, we're going to take this a little further, because our end goal is always to solve for the derivative. So for example, here we'd have to take one extra step to solve for y prime. Same thing here, take one extra step to solve for y prime. So for example, if I was solving for y prime here, I would set this equal to 0, subtract the 1 over, and then divide by 3. I would just isolate that y prime like if you would like isolate y in algebra 1, okay? So I wrote it out for you in some steps. Nothing too crazy. You're going to differentiate both sides with respect to x, which is what we did here. So we did the derivative on both sides with respect to x. Then you're going to move terms with dy dx or y prime, whichever one you choose to use, to the left side of the equation, and terms that do not have that to the right. So just like in algebra 1 when you were solving for, let's say, x, you would move anything with an x to the left and anything without to the right. Same thing here. Then on that side that you have the dy dx or the y prime, you're going to factor it out, divide everything else over so that you can isolate dy dx or y prime. And then once you have it by itself, you are done, okay? Because dy dx or y prime means derivative and they tell you to solve for the derivative, that's what you want to get by itself, okay? So these problems are not difficult, they're just a little lengthy, so let's check them out. All right, looking at this first example, it says find dy dx for this equation, okay? So that means I first have to do the derivative, okay? This is obviously with respect to x, and this is not an x. So here I'm going to have to do implicit. Here I'm going to have to do implicit, Here I can skip it because it's the same variable. And then here I'm just going to do the derivative of -4. -4 is a constant. Derivative of a constant is just 0, okay? So for this example, I am going to use the dy dx notation, and then here I'll use the y prime notation just so you guys see both, okay? So derivative of y cubed. First do your regular derivative, 3y squared. Because it's a different variable other than x, I have to include its dy dx. Next term, plus derivative of y squared is 2y. Because it's a variable other than x, I have to include dy dx. Minus derivative of 5y is just 5. Because it's a variable other than x, I have to include dy dx equals derivative of -4 is 0. All right, you are done with the calculus at this point. The easy part is over. So now we move on to the next step. Anything that has a dy dx goes to one side, and anything, oh my goodness, I forgot to do the derivative of -x squared. Look at your crazy teacher. All right, sorry, we had stopped here and I totally skipped over this poor little guy. Derivative of -x squared is -2x to the first power. And because x and x are the same variable, I do not have to do the implicit portion. And then, sorry, derivative of -4 is 0. I apologize. So now, anything that has a dy dx is going to go to the left, and anything without is going to go to the right. So dy dx, dy dx, dy dx. This one does not have a dy dx, so this one is going to go over to the right side. Once you get good at this, guys, you're going to feel like you can skip a step or two, or I don't want to say skip. You can combine a step or two and do it at the same time. Feel free to do that, okay? Okay, so now that all three of these have a dy dx in common, I can factor that out. So I can say dy dx times 3y squared plus 2y minus 5 equals that 2x. And now lastly, I just want to get this by itself, so I'm going to divide all of this over. So I can say dy dx equals 2x over 3y squared plus 2y minus 5. And the moment that I have dy dx by itself, you are done. This question is finished. Okay? Alrighty. Let's look at the next one, okay? So in the next question, I'm going to do one thing different. Instead of using dy dx, I'm going to use y prime for those of you that choose to use that notation. And we're also going to do this next question at a specific point, okay? I'm going to show you two completely different ways of solving this. The first way is going to stay more consistent with what we did here. The second way, I'm going to change it up a little bit, but it is going to be a much faster version. So again, I'll expose you to both so that you can pick which one you want to do. If you are in AP, because the day you take an AP test, you are timed and you are on this marathon, I'm going to encourage you to do the second one, okay? So let's check it out. Find the slope. Slope means dy dx, okay? The change in y over the change in x, yes? So y2 minus y1 over x2 minus x1 of this function at 3, 1. So the first method we're going to do is we're going to do the same exact thing we did here. We're going to do this whole derivative process, isolate dy dx, and then we'll plug in. Remember how before I told you ignore the y because we didn't have y's, and you would just plug in the x? Now we have x's and y's, so you're going to plug both of them in. That's the first method we're going to do, okay? So I'm also throwing you a big old chain rule happening here. You see how we have an inside and we have an outside? And over here, I'm throwing you a product rule, okay? So let's take our time. Derivative of the outside, I'm going to multiply the 2 to the front, so I'm going to get 6. I'm going to rewrite the inside. I'm not doing the derivative. Subtract 1 from 2, so it becomes 1. Times, now I have to do the derivative of the inside. Derivative of x squared with respect to x is just 2x, and then I get to skip implicit because it's the same variable. Plus derivative of y squared is 2y. Because it's a different variable, now I have to take implicit into account, and this time I'm doing the y prime. So one more time, I did derivative of the outside, 2 times 3 was 6. I rewrote the inside, now it's to the first power, times I did the derivative of the inside. 2x without implicit plus 2y with implicit because it's a different variable, okay? Equals, now let's do this right side. Feel free to treat that as 100 times x times y, and you can just do the product to x and y. Okay, so I can leave a 100 out here as a coefficient. And now the derivative of x times y. So I'm going to do first, just rewriting the first, times derivative of the second. Derivative of y is just y prime plus derivative of the first is just 1 times rewrite the second. You are done with the calculus. You are done with the hard part. Now comes the algebra. Excuse me, you're done with the easy part. Now comes the algebra. Okay? So, to start this off, there's going to be a lot of distributing and foiling, so be careful, okay? I'm going to distribute this 6 in. On the next step, I'm going to have to FOIL these. And then here, I'm going to distribute the 100 in. Okay? So I'm going to take it step by step so we can go slow. Feel free to go a little faster if you feel confident. So now on this left side, I still have to FOIL, okay? So these two have to get multiplied. That's the next step I'm going to take. I'm just going to rewrite this right side. So I'm going to say 6x squared times 2x. I get 12x cubed. 6x squared times here, all I can multiply really are the coefficients. So plus 12x squared y times y prime. So I did the 6 and the 2, which got me the 12, the x squared, the y, and then the y prime. Plus, I've got these two, so this is 12y squared times x. And then now these two, inner, outer, first, inner, outer, last, okay? So I've got another 12. I've got a y squared and a y, which gives me a y cubed. And then I have a y prime. And then I'm just going to rewrite this right side. So I told you guys, the calculus is the easy part, is the algebra that's annoying. So now I have this term has a y prime, this term has a y prime, and this term has a y prime. Those three I'm going to want to have on the left-hand side. This one, and this one do not have a y prime, so I'm going to move those to the right-hand side, okay? So let's start with my ones with my y prime. So here I have 12x squared y prime plus 12y cubed times y prime. And this one I'm going to have to subtract to the other side. So minus 100x y prime equals, now let's start with the ones without. It's on the currently on the left. I have to move it to the right, so I have to subtract. It's currently on the left, so I have to subtract it to the right. And this one is already on the right side, so I'm just going to rewrite it. Okay? So now I have my y prime, and my y prime, which I'm going to factor out. And now, just to isolate this y prime, I'm going to divide all of that over, and we can say y prime equals all right, so I isolated my y prime. All right, if you're yelling at me through the screen, I just noticed a mistake here. I forgot to write my 100 next to this y. So 100 times y would have given me a 100y here and a 100y here. Okay. I apologize for that. It would have also left me with a 100y here, here, and here. So sorry for that. All right. So now we have to take into the account that they want this, and here's a notation you're going to start learning in calculus. So you put a line, which means at, actually we don't have to put x equals, we can just write the ordered pair. At 3, 1, which just means you're going to rewrite all this, negative 12. Anytime you see an x, you're going to put a 3, and anytime you see a y, you're going to put a 1. So and we're going to plug all of this right into our calculator. By the way, if you are in AP and this came up on a free response, you would be able to stop right here, because technically the only thing that's left is arithmetic, and that value that comes out is your actual answer, okay? All right, so when you put that in your calculator, if this was a multiple choice question, you would get 13/9. Okay, so the slope of that function, specifically at 3, 1, is 13/9. Okay, so this was the long way. I've got good news, there's a shorter way. Okay, so again, the long way was first isolating y prime and then plugging in the points. The second way we still have to do the derivative first. So our first step would have been the same, okay? So remember, this first step was my derivative. Ignore the red. I'm just going to rewrite my derivative. All right, so there's my derivative. Now, the faster way is, if this can only happen if you have a point. If you don't have to a point, you do have to just go straight to getting y prime by itself. But if you have a point given, you can plug in your point now. So plug in point. Okay? So I'm going to say 6 times, all my x's should be 3's and all my y's should be 1. So I'm going to say 3 squared plus 1 squared, 2 times 3 plus 2 times 1 times y prime equals 100. 3 times y prime plus 1 times y is just y, so I'm just going to put my y, which was 1. Okay? Now at this point, it's much easier to work with things because I can say 3 squared is 9 plus 1 squared, this is 10. So this portion right here gives me 60. Okay? Times this gives me 6 plus 2y prime equals, if I distribute, let's mark this in red. If I distribute this 100, now I have 300 y prime plus 100. Okay? If I distribute the 60, I have 6 times 6 is 36. Add the 0 in. Plus double 60 is 120. Y prime equals 300. Y prime plus 100. I have a y prime here and a y prime here. Those two are going to the left. Since these two do not have y primes, those are going to the right. And now I can say 120 minus 300 gives me negative 180 y prime. And then I have 100, and I'm going to subtract the 360 to the right-hand side, which gives me negative 260. Y prime equals negative 260 over, negative 180, I'm sorry. And then remember, if you are doing AP, the moment you have y prime by itself, you can stop. But if not, if it's multiple choice, you'd reduce, and that reduces to 13/9. Okay? Do remember, if you're taking AP, the majority of the test is no calculator. So another reason why I like this one, it's way easier to do without a calculator than this would be to do without a calculator, okay? So 2 versions. You could tell the top one's a little longer than the bottom one. I rather see numbers than extra variables. And remember, you can do this whole problem instead of writing y prime, you can write dy dx. All right, guys, let's take it up a notch with this question. Find, what does that notation mean? I've shown it to you before. Hopefully you're remembering that that means the second derivative. Okay, that 2 there in between the d and the y, and the 2 right there after the dx means second derivative. So bear with me. It sounds so much more complicated than it is, okay? We're going to start off by doing the first derivative. And you can see by the denominator that it is with respect to x. So the derivative of the first is going to be 8x to the first power. They're the same variable, so I do not have to do implicit, plus my second term, derivative of y cubed, 3y squared. Because it's a different variable other than x, I have to include implicit, okay? And then equals derivative of 9. 9 is just a constant. We get 0, okay? We're going to take the same exact steps that we did on the last question and isolate y prime. So I'm going to subtract this 8x over, and then I'm going to divide by this 3y squared. So we are done here with step 1. We found the first derivative. Now to do the second derivative, I just have to do the derivative of this, okay? And because this is division, this is your quotient rule. So let me just go marking things for you. Here is my first derivative, okay? And then to move on, we're going to have to do quotient rule. So my notation is going to look like this. Now moving on to my second derivative, and quotient rule is low, so just rewrite the bottom. D high, derivative of negative 8x is just negative 8. And because it's the same variable as the denominator, I do not have to do implicit. So there's my low, D high, minus high, just rewrite, D low. Derivative of low is going to be 6y to the first, and because it's a different variable other than the denominator, I have to do my implicit, okay? Over low squared. All right, so on this next step, this is going to happen every single time you do the second derivative. When I start cleaning, like I'm going to combine and multiply that negative 8 with the 3 and so on. But before you start cleaning, this y prime right here, you need to clean. And the way I clean y prime, well, I found a moment ago what y prime was. I need to plug that in. You see that? If we found that y prime was this negative 8x over 3y squared, that's what I'm going to put in that spot, okay? And again, I'm going to encourage you not to clean this yet, because you're going to see how it cleans up nicely first without it. So let me write out that step. All right, so all I did was plug in what my derivative was, okay? This is all I did right here. So now, the reason why I didn't want you to clean anything else yet is because this denominator should clean out pretty nice with what's over here, okay? So, notice that this 3 is going to disappear because it can reduce with this 6. So 6 over 3 would just turn into a 2. And then y squared and this y is going to disappear. And the square disappears. I do still have one y left over. Okay? If I have one y left over, we talked last lesson about when I have a fraction within a fraction, how I can clean that. And the way I do that is by multiplying top and bottom by that extra denominator. Okay? So that is going to distribute over here, and then this one's going to distribute into here, okay? So let's start off with this first one. 3 times negative 8, okay? I've got negative 24. I have this y squared times this y, so I have y cubed, okay? Then I have, let's take a look at our negatives first. I have 1, 2, 3 negatives. Negative times negative is positive. Positive times negative is negative, okay? Then I have 8 times 8 times 2, okay? That gives me 128. And now I have an x here and an x here, which gives me an x squared. And then this y will end up canceling out with this last leftover y that I had. Okay? All over. This squared needs to go to the 3 and to the y squared. Okay? So 3 squared is 9. And then an exponent to an exponent, I multiply. So I have y to the 4th times this last one, okay, which ends up giving me y to the 5th. Okay? All right, at this point, you are done with the problem. Let's just go over some of that algebra that happened. Because, again, I feel like the actual calculus, the quotient rule, the implicit is really the easy part. It's just all of this algebra we have to clean up after. This is our final answer, okay? So one more time, we multiplied the 3 and the negative 8 to get the negative 24. The y squared, right? But then this y gets distributed. Let me draw some arrows for you here. Over to this guy. But also over to this guy. So again, y squared with that y gives me the y cubed. Negative times negative is positive times this other negative gave me a negative. 8 times 2 times 8 is 128. I have an x here and an x here, which is the x squared. And then remember, the whole purpose of this y was to cancel out with this one to not have a denominator anymore, okay? And then here we have 3 squared, which is 9. An exponent to an exponent we multiply, which gives me to the 4th. And then a 4th times y to the 1st. When we're multiplying, we add the exponent, which is where I got the 5th. All right? And that is you doing a second derivative implicitly. All right, last 2 questions here. Write an equation of a tangent line to this function at this point. So remember that equation of a tangent line, we're going to write our y minus y1 equals slope times x minus x1. So we're going to end up writing this equation. And these two are given to me right here. So I have the majority of my answer there. What I'm missing is this, which means slope. I have to find the derivative of this at that point. So that's going to be the part that's going to take me a moment. Let's do that here. This, whenever they don't specify, guys, you can assume that it is with respect to x, okay? If it's a word problem, like we're going to see in next lesson, you can assume that it is with respect to time. So with respect to x, I have my derivative, which is 6x squared. This is with respect to x, so I don't have to do implicit. Minus, here I have multiplication, so I'm going to have to do product rule. Okay? So I have first times derivative of the second. Okay? Plus derivative of the first times the second. Okay? That's my product rule. Now I can move on to the next term. Plus, derivative here is 3y squared. But because it's with respect to x, I have to do implicit. And then minus 1, derivative of a constant, is just 0 equals 0. Okay? Let's go ahead and do the short version where we plug in the 2 and the negative 3 next into our x's and y's. All right. And now we're just going to take a moment to start to clean. 2 squared is 4. 4 times 6. Minus, I'm going to clean the inside of this product first. Make sure that you're very neat with your parentheses, guys. You'd have to finish this whole product before you can start combining, okay? So now I have 4y prime plus 2 times 2 is 4. 4 times a negative 3 is going to end up giving me a negative 12. And then plus, make sure you follow PEMDAS here. Negative 3 squared is 9. 9 times 3 is 27. Okay, and because I have to finish the product rule first, that means this negative gets distributed. So I have 24 minus 4y prime plus 12 plus 27y prime equals 0. I'm going to combine like terms. Okay, so I have a positive 27 and a negative 4, which gives me 23y prime, and I'm going to keep that on the left. And then I have a 12 and a 24, which gives me a 36, but I want to move that 36 to the left, excuse me, to the right-hand side, so it's going to be a negative 36. Okay, isolate y prime, negative 36 over 23. So this right here, guys, is my m, is my slope. Okay, so now that I found my slope, I can write my answer. I can say y minus y1 is a negative 3 equals my slope, which I found was negative 36 over 23, and then times x minus x1. Okay, you can leave it like that. You can say y plus 3 You could also isolate the y. These are all different options for your answer. No need to keep cleaning. If this is a free response, once you have it in the equation, you are done. Okay? So feel free to leave it just like this. All right, guys. And for our last question, the only thing that's going to change is its equation of a line normal, which means I want, once I find my slope, to do a perpendicular slope. So I'm going to flip the fraction and change the sign. And I also threw at you some trig functions so we can practice those. Okay, last question. Write the equation of the line normal to sine times cosine equals radical 2 over 4 at this ordered pair. So again, I want y minus y1 equals, we're going to do negative 1 over m because it says normal, which is the same thing as saying secant. It's one of those synonyms, times x minus x1. Remember, we have our y1 and our x1 right here. And now I have to take a moment to find m. So m is my derivative, okay? So the derivative of sine times cosine, I have a product rule going on, okay? Here's my first function and here's my second. So first times derivative of the second. Actually, guys, you know what? I apologize. Let me fix this question. I'm going to write this as cosine of y because I just realized it wouldn't be implicit if it wasn't. Okay? So first times the derivative of the second. Derivative of cosine of y would be negative sine of y. And because it's with respect to x and that's not an x, I have to do times y prime or dy dx. Okay? Plus derivative of the first. Okay? Derivative of sine is cosine of x. And then rewrite the second. whoops, getting a little too close to this guy. And then equals radical 2 over 4, that is a constant, so derivative of a constant is just 0. So this is just going to be equal to 0. So now I can say sine, I'm going to plug in my x, of pi over 6 times negative sine of the y value, which is pi over 4 times y prime, plus cosine of x, so cosine of pi over 6 times cosine of y, which is pi over 4, and we said it was all equal to 0. Okay? So now onto our unit circle. Sine of pi over 6, we get 1/2 times negative sine of pi over 4 is radical 2 over 2 times our y prime, plus cosine of pi over 6 is radical 3 over 2, and then cosine of pi over 4 is radical 2 over 2. Okay? If we multiply here, we get negative radical 2 over 4 y prime, plus we multiply these two, radical 6 over 4 equals 0. Isolate y prime. Oops, I put a 3 there. Now this is being multiplied, so I'm going to have to divide it over. Again, I'm going to go slow, but feel free to go a little faster. When I'm dividing fractions, I keep change flip. I multiply by the reciprocal. Okay, these 4's cancel out. The negatives cancel out. And remember, when I am in multiplication or division, I can combine the inside of radicals. So this just gives me radical 6 over radical 2. 6 divided by 2 is just radical 3. So this is what my slope is, okay? Now, when I'm coming down to write my equation, y minus y1 equals, I'm going to say negative, I need to flip it, 1 over radical 3. Do not worry about rationalizing. That is not needed in calculus. And my x1 is pi over 6. And you are done.